Good. So I'm going to share the data set in the chat. Mhm. So it's called the disease data. Okay, let me close this. Then I'll reshare. So I will share that script after the way. So I'm hoping we will just follow and code along. Let's see how that goes. It's first time we are going to do that. So let's see how it goes. Yes. So I've just shared the data set inside the chat. In case you want to follow a bit, yeah, you are welcome. Okay. So I'm just going to use the first 5 minutes to give overview. So before that, I appreciate you for joining me today. I'm Ebenezer Senu, and Ghana Research Community, we are very kind of happy
Dr.
this
Senu,
moment for
Dr. Senu.
joining. Yeah, so yes, Ahmed. Yeah, good, Ahmed. Yeah. Yes, I mean, Ben, you are very welcome joining us from Ghana Research Community and also the Elite Research and Data Science Institute. Continue to follow us and make sure you join all our trainings. If you've not heard about us before, or someone just shared a link to you and you join, let me show you some of our websites and the things that we do. Mm. Mm. Yes, so this is the Ghana Ad Users community. It's a wonderful community. I'll say this, we are the kind of, we are championing the R styles in Ghana. So if even you are outside Ghana, most of the training are online, you can feel free to join. So we can be checking the website on the things that we do. So you could see that next year, yearly, we have this conference that you can always join. And next year, it has been announced ahead of time. So you can always follow us on everything that we do. Also, if you look at the Elliott Research and Data Science Institute, this is also our website. You can always follow us. Whatever we do, we are very active, either linking everywhere. Or you can also click on the YouTube and go to our YouTube page and see some of the stuff that we've posted. The same thing in Ghana RSS. If you go to the YouTube page, you will see that you've done a lot of stuff that you can watch freely on your own. Some of the previous webinars that we've done that you see and you benefit from that. So today we are going to look at something very interesting. Let me open the data set we are going to work. Mostly if you happen to join any of our training, you see whatever we do is practical. We focus on doing the practical base, not theory. With a bit of theory, you know the theory. But if you join our intensive week-long training, you see we take you from the theory to practicals. But most of these short webinars, we really don't have time, so we go straight to the point. But we try to explain some of the science behind everything that we do. So, at being any researcher, your goal is to go and take data or to go and do a lot of lab works. Then you bring data. But as I will say, if you go spend millions and take your data, like laboratory analysis and the rest, or clinical trials, you should spend years, 20 years just taking data. That is nothing. If you don't do quality data analysis, bring insight to the data and publish. So all the years you'll be using to do your research, all the money you've spent will go on a waste. If at the end we don't produce the quality data, analysis for you. So that is why the peak of everything that you do is the data we are producing. And if you're able to do this, you'll be able to do a good writing, and each and every day you're going to publish in high impact journals. Day in, day out, when we review papers from other countries, we see the kind of things that are going on. So that puts us in the other peak that we are doing well and we are able to compete globally wherever you are. It's the same quality we are giving you. So today we are trying to go into this data. So this is just a data set that has a disease, okay? So the first thing, as someone that's going to analyze data, is not just about knowing the software, but it's about what the software is going to analyze for you. So we first have to understand the data. What is in the data? So if you are the person that generated your own data, already you might know what is it, but you know your objective of your analysis. But if someone brought a data to you and you are the data analyst, you want to analyze it, then the person will explain the data to you. So today I just sent you this data. Then I have to explain the data to you that this column is just the patient ID. We are not going to use it. It's just to track that. Oh, how many participants do we have? So in this data set, we have over 315 participants. Then we have a column that has a disease, okay? And within a disease, some people said no, some has yes. So I'm not going to go into detail what kind of disease. So we are just assuming it's any kind of disease. Then we have the age of the participant. We have the age group. So from the age, we are able to categorize them into what? Age categories. So in a typical biostatistics class, we tell you that this age is a continuous variables. Why? Because it's just different numerical variables that are being entered. Each participant is likely to have a different what? Numerical variables. Then this can be what? From the age, we can what? We also group them into a particular groups. So in future training, we will tell you how do we even create groups. What is the science of it? There's a way we do it. We don't just stand up and say that I want to create age group 20 to 29, 30 to 39, 40 to 49. We don't do that. There's a way we do that. So we teach you in the subsequent trainings. Yes. So it means that age can be handled as two different variables. One as a continuous variables and two as a categorical variable. So continuous variables are the variables that are from the name continuous difference. There's a lot. But for categorical variable, they are come in levels, attributes, or kind of specific groupings. So they have limited, it can be like 1 to 5 groups. So that one, they are very few. We can have gender, like male and female. We can have marital status, educational level, and residence. So you could see that this data set, disease is yes or no. It's just two groups. It's either the person belongs to the disease group or do not belong to a disease group. So we call this a categorical variable in a typical biostatistics. But in R, we are going to call it a factor variable. So we are going to look at that. How do we handle that? Then we have another age group. This is also grouping. So if I filter this, Control Shift L, then we can see that this is 18 to 35, 36 to 45, 46 to 55, 56 to 90. So it's just also a phase grouping. So at least because there's no any missing entries, each person kind of belong to a particular hot grouping. So we call it a categorical variable. Then we have gender. If you look at gender, within it we have male, female. So because we have phase grouping, we call it categorical variables. Then we have what? Divorce, marriage, single, widow, like the educational level. So we can even further stratify categorical variable into what we call nominal categorical variables and ordinal categorical variable. So a typical example is educational level. You could see that typically someone will move from no formal education to primary to GHS to SHS to tertiary. So if the categorical variable can be ranked in a particular order of preferences, then we call it ordinal categorical variable. But if it cannot be ranked, like gender, anyone can choose to bring male or female first. We call them nominal categorical variable. But mostly in statistics or data analysis, we handle them similarly. It's just most of it, if you look at analysis that we do, the same statistical text apply to them. So why am I emphasizing on this? Because today we are going to look at how do we handle the categorical variables in terms of the simple inferential statistics and predictive analysis. That's what we are going to do today. We are not going to do more into details, but I just want to give you a gist of one way we can do this. In SPSS, we can easily analyze dates, very simple, but it's good. We look at how do we also use the same knowledge and use the R script to do that. That's what we are going to do today. And I hope you are going to enjoy today's sections. And thank you again for joining me. Do you have any question? Okay. So let me also give you a brief intro to R. So R is just one of the statistical software. This is R interface. So in fact, let me check and want to make sure you're good. Let me try and close some tabs. Okay. Now let me reshare my screen. So first, I want to, those that are total beginners, just a brief, because if you join our subsequent training, you will see us giving you more details into that. Today, I just trying to boost your interest into this software, very interesting software. So if you look at the R itself, this is R that we are using, we work on. So you could see that on my desktop, I have R 4.5.2. So that's the R itself. So if I launch it, this is how it looks like. But working here is if, for example, if you want to do anything here, you can still work here. Okay. Whatever you want to do, you can still do it there. 2 plus, then. So if we work 2 plus 3, it give you 5. Okay. So this is the console of the base R. But working here is very, very complicated. One, it cannot even give you right-time track of your code, whether there's an error and all those things. Until you are done, it doesn't give you warning. It doesn't give you a user-friendly interface. So because of that, that is why we have the ID. So they have the R Studio. So today we are going to work on the R Studio. So this is the R Studio. So this is how the R Studio interface looks like. And it has tabs and it gives you kind of tracking that you can do when you are writing the codes. So that's just one of the, and currently there's positron. So some of the stuff, mostly I do Python with positron. So you can also now do R coding in positron and together with the Pythons, which is good. So it means that if you want to kind of work easily, first, what you do is that you first download the R itself, then you download the R Studio. So in this case, you just have to go to your browser. So let me show you. Then you say, you can just even say R Studio download. Okay. Then you go to their website. You can go to the POSIT website. Then you come here. It will have two. Let me show you. So if you come to R Studio, I want to show you. One of the website has both. Yes, the first one. So this one has both the R itself. So you just download and install the R itself. Then you come back. So step one and then step two. Okay. Then you come back and you download this one also. And you are good to go. And you have this interface we are going to work on. So a typical R itself first, because we are not doing a lot of intro today, you have the R script itself. This is how it's very blank like this. Then we are working on. Any question up to this stage? Any question, you just free to ask or put in the chat. If not, I assume you are enjoying whatever is going on. Yes. Yeah, so when you are beginning at first time, you see anything, even in your environment or the space and everything. Because they out for the past weeks, I've always by my are trying to do a lot of stuff. So you see my house studio very messy, has a lot of things going on. So today, that's what we are going to do. So it's either you are doing with the R file or the Quarto Markdown, R Markdown. So those are most of the advanced stuffs that from the R script itself, that's the base working interface. Then before they move to the R Markdown, currently they are working with Quarto, which is very interesting. So let's see what we do. So today, I'm going to work with Quarto document. Then we are good to go. Any question? Okay. So let me also take you through the page that we have. Mostly this in a typical base R, this is kind of where you write your script or the source. We have the console down here. Mostly if you are using the base R script, if you write your script here, you see the output here. But in the Markdown and the Quarto, which today we are going to use, you see both kind of, you can write a lot of text and also the code here, and you also see the same output with displaying around this. Now, if you come down bottom to your right, you will see also a lot of stuff going on, like the plot. If you do any plot, it will come here, packages and the rest. That's what you are going to see. And the environment, you can import data. So you could see a lot of data in my environment. Yes, so yes, we are going to start right from that. We are going to import the data. So the first thing we are going to do is to import in data. Yes. Great. So it means that we are good up to this stage, and at any time you can do this. So I'm just going to share only my art studio, then we start from there. Okay. Let me know if you can see from our studio interface.
Yes.
Okay, yes. Okay, so as I said, I sent you an Excel file. So before that, we need to what? Get the data. So mostly, I tell people that the universal recipient of a data is kind of in Excel. So you could see that people that are being taught SPSS, then they want to try and enter their data into what? SPSS. We don't do that. So regardless of any software that you are being taught, most often you enter your data in Excel so that you can easily import to any other software. So software like R can easily accept those kind of data also easily that you can work with. So one thing I want to also let you know is that R is a language. I don't know. R is a language. When I say it's a language, Ruby, what kind of language do you speak?
She English
Mhm. Yes. So
uh,
when did you start speaking English?
from primary one.
Primary one, yes. But you learned that in the class, right?
Yes. Yeah, that's for me.
Exactly. Exactly. So why am I asking this? So the reason why I'm asking is that so R is also a language. That's why we call them programming language. So we don't just kind of jump and you think that you can start speaking the R language. No. That's why we need to also start learning from the ABC before we form words, before we construct sentences, before what you can speak the language of R. It's the same thing. You can't say you know R, so you can write in Python. You need to go and what learn the language of Python before you can use it. So the same thing. So this software has a set of instructions that you need to understand in order to easily write their script and follow. So this one, they have their language in form of functions. Okay, in form of functions. Do I need to be connected to Wi-Fi to use? No. So, but to download those R and the R Studio, you need to be connected to the Wi-Fi. So when you download them, that's all. You work on your PC. Yes. So these languages are in the form of functions. So if you don't understand the kind of the vocabulary of R, you can't use what R. So the same thing, if you don't understand the vocabulary of English, you can't use English, so you can't speak English. So that's just the basic principle. So these functions are, so the language of R is in the form of function. So for example, if I say SQRT, then I put 9, then it give me what? 3. What is SQRT? So from here, you can now understand the meaning of SQRT. It means that what is the square root of 9? It means 3. Why? Because I understand the language of this R. So it's the same thing. You don't have to be worried if you are just totally new. You are just, no. You just have to understand that you need to now start from the basis. Then you build to a level that you see the experts that are also writing their code and the rest. That is all. So it means that you need to understand the function of the R so that you can use the many functions. So if you get to know a lot of functions, that's why you can use them. It's like you get to know a lot of vocabulary, then you can speak the English fluently like that. So these functions are also now built or packaged into what we call packages. So it means that if you want to use, it's like you want to speak Chi or you want to use Chi dictionary, you need to go and download what the Chi or the you have to understand what a Chi language. You can't just go to the English and go and enter a Chi word in the English. You go to the Chi or dictionary to go and what use it. That's what I mean. So it means that a particular function you want to use depends on what where that function is from. So we call them packages. So today, one of the packages we are going to use is the tidyverse. So it means that I'm working with a cattle markdown. So that's why you see me. So mostly we will just say install, then we say tidyverse. So this is the tidyverse, then we install it. So I've already installed this. That so install this. But when you install it for the first time you want to use, then you say library, then you say tidyverse. So in that case, that one, the quotation marks are optional. Then you can now call it. So if you install it, you only install it once. Then if you are using it, you always activate it by hot calling it. Then you can now hot use it. So mostly some of the things we are going to do, they are within hot this tidyverse package. Okay. So we've also have data. So what do? We have to now hot get data. We get the data into it by hot importing them. So how do we import them? Mostly I always show the class one way. So you come to the environment, then this symbol, you can see that import data. Then from hot Excel, the data I sent to you is in Excel. So you click on the Excel. You click Excel. Then you say browse. So this Excel requires a particular package, okay? So, but the good thing is that if you've not installed the read Excel function and you try to install it, it will ask you to install, and you just click on yes and install, and you are good to go. So we get this. Then I have to go navigate to folder. So I created a folder for today's webinar. So I'll click on the data set, the disease data set. Then I said open. Okay, I'll click on open. But as we do in other software like SPSS, whenever I'm teaching SPS and other software, I always talk about these things. Within a particular data sheet, there are different sheets, okay? Within a particular data set, there are different sheets. So if you look at the data set I sent to you, within this Excel data set, there's one that was raw data. So this raw data, you could see that everything is still in West. Then there's another one that I said clean coded. So it means that that data I further clean from the first one, then I recode them into numbers. Because a lot of the statistical software are able to handle what? Things easily in numbers. We don't kind of want to see them because we want to handle them in numbers, not in alphabet. That's going to affect the kind of analysis we're going to do. So if you're not able to clean or recode your data into the right format, automatically it's going to affect your entire analysis. Okay, so that's why we reclean and recode the data format into numbers. Then we can easily handle. But if we come to visualization, yes, someone can please reshare the data. Let me do that. Let me reshare for you. So I'm going to reshare the data one more time. Okay. Yes. So so it depends on the kind of analysis I'm going to do. In fact, when it comes to R, some visualization demand that the groupings supposed to be still in alphabet. That makes things very easy for you. But today, most of the we are going to do in numbers is fine. That's what we are going to deal with. So when this you clean coded. So what I mean here is that you just select the right sheet that has the right data set for you. Okay. If you get here, don't click on import. First, select the right sheet. Then you come here, you make sure just copy the script. I don't want you to click import. So you copy. I want you to just copy the code, the code preview to where your data is. Then you say cancel. Then you paste it. So that's why you get. So for me to just write a very long code like this to track, I just get there then like that. And this is how we get the data sets too. Oh, I see. So it means that this is the code. Someone can write this long code. Or another way is that you kind of change your working directory. Okay. Then you know that you're working in the same working directory and you just read the files from the working directory. But don't worry, because sometimes you may try to get code from different sources and your working directory will be changing as you are working. So this is the easiest way to get data in your RStudio and you work with. So the data name is very long, so I can rename it into DD data. Okay, DD data, then I'll just say read Excel. This read Excel is what is going to read the data from the Excel. If you are importing data from other format like CSV, Stata, there are other functions. So this is a function that we are going to read this data. So DD Excel. Then it means that if I said I run this code, running this code, you can select everything. Then you click on this run or control and enter. So mostly I'm going to use the shortcuts, the control enter. So if you see me that I've run the code, control enter, No worry, because I'm using a shortcut. Then it will run it. So it will give you blue. So in the console, you'll be seeing blue, blue. Always when you see blue, blue within the console, it means that yes, good job. It's the right things. But if I have error, it give you what? Red indication. So that's why we can compare this to the R. The R base itself, if you are working there, it doesn't give you all those things. So RStudio has improved with a lot of format that it's making work very easy. Now you can even view this data set. If you are put here, then I said view this data set. It will open into a new hot window. Then to see that this is the data set we've imported, the patient ID, disease, age group, gender, educational level, residence. So this is the data we've imported nicely and we are going to work with. Okay, any concern up to this? Yes, we are good. If we are following, put one in the chat. I have to make sure I'm not talking alone to myself. Those that really understand too, yes, you can always, yes, yes, great, great, great. Yeah, I have to make sure we are all having fun. Today is not really serious. We are just playing around, making fun of R and data analysis. These stuffs are really fun when we enjoy doing them. Yes, I just want you guys to appreciate, to position yourself for 2026, to say that one of your kind of inspiration for 2026 is to master in R, which I'm happy about that. Yes, great, great, great. Yeah, so now we have data in it. Then this data, okay, is what we call is in a data frame. So it's a data frame. So what is a data frame? Today, I'm not going to talk a lot about a lot of information, but I'm just going to hit on some of the things that we know. So one thing is this is a data frame. A data frame has a column with different variables. Sometimes I'll teach people the difference between a variable and a data. They are all differences. So it has what, a column with different variables and a rows with for different participants. This is what we call data frame. So if you switch to a different column, you see a different variables. If you switch to different rows, you see that it has different participants. So, but we can still see what is happening within this data. So we can say that XR string, then we say we bring the data. You can always also copy the data. Then we kind of see this data. So this str structure is a function from the tidyverse package. Okay, there are other ways to look. So here, I just want us to see the entire data structure. Okay, so you could see that these are the variables we have in the data because this is going to inform us the analysis we are going to do. So we have to see the data, then we are going to use it to do a chi-square test. Then we look at after we do chi-square test, whether we can do facial exact test. Then we can predict one of the group. That's the main objectives for today. And so what inform us or what are we going to do? So, but before that, we need to check the data. Are they in the right format for us to what? Do the analysis? Because if you come to patient ID, patient ID what start with what? An alphabet. So automatically R by default is seeing them is what? A character. So in our character means it starts from an alphabet or it starts alphabetical what means. That's how it looks like. Yes. Yes. So yes, strength. Yes, how I say strength is also in base R. Yes, it's fine. Yes. But there's another one. Let me also use Grims. Yes, I think Grims is another function. So one is I know one is base, one is in more of tidyverse. Let's see. Okay. So some of the functions, some of them are in base, some of them are also in tidy base. So this too is, so if you get to know a lot of the functions, you kind of just use them. Sometimes because if you install all the packages, you don't really know which one is coming from which one. But it's fine. So before you start your data analysis, you just kind of start. You install your package, then you are good to go. So one of the two main is the structure. Let's see the structure. Structure is telling us that patient ID is a character. So character means what? It's an alphabet. So because automatically the RStudio is what? Seeing that it's starting with alphabet, it assumes that everything is alphabet. Then it sees everything as a numerical variables because they start with numbers. It's the same thing like the grapes package that sees character and then it says it's double. So both depend as it depends on the function you are using. That gives you the kind of labels. But in R, both numerical. So if you could look at this base function, it says that these are in numerical variables, but this is saying that it is to double. So if you see doubled or you see what numerical, they all start from the same thing. It means they are numbers. So we treat both numerical and numerical are the same thing. They all mean the same thing. It means that they have numbers and they are good to go. So you don't have to worry. So sometimes, yeah, the typical example is between these two functions where one is telling you is what numerical, one is telling you is what a double. So they all mean alphabet. So now, what is the implication? Implication means that this one, they are all seeing this as a continuous variable. That's the baseline thing we have to know that this numerical variable means that it means it's a numerical variable, but we want to see them as a factor. So you could see that if you look at the data set, disease is 0 or 1, age group is 0 or 1. The only continuous variable or numerical variable that we can say is the age, which R had it right by default. But if you look at the other variables like the disease, the age group, gender, marital status, educational level, is seeing them as a numerical variable. So what do we do? It means that we need to first recode or transform this data so that we tell them that, no, see them as a categorical variable so that we cannot use them in the categorical analysis. So how do we do that? So in R, most of the convections start with ax dot. So if you say ax dot, it will give you a lot of prompts to do a lot of convection. So if you want to convert a variable to character, you say ax character. The same thing if you want to convert it as compress, as complex, as data frame, like that. Up to so different as date. So all the conversion you just have to start with ax, then dot, then you select the next prompt. So today we are just interested in one particular one, which is as a factor. So this one, that's what we are going to use. So, but what do we do? So this is the data set we've renamed, okay? So I would say that this data set, if you go to this data set, you use the dollar symbol to self-filter a variable from the data set. So I would say that go into this disease, then you assign. So we have what we call operators. One of the operators is the left assignment operators. This left assignment means that whatever we are going to write at the right will be now what equalized or assigned to what is in the left. So we are saying that this disease as a variable in the data set, we want to what assign this as a factor. But what is this again? We go into it, then we said what disease again. So what is this create means? We means that we want to what this disease, within what data set this. We want to convert it as a factor and replace it back in the data set. Then we said, okay. So before I run it, let me show you another base function, class. So you can say class of the same variable. It tells you what is numeric, right? Which are the main string and the grams has given us overview. So now, if you say if I run this, then I come back and now I say class of this hot data, then into bracket disease. Then I can say that it's now what a factor. Factor means is what? Now a categorical variable. Then we can even see that what is the levels. There's also another what base function we call levels of the same or data set. Then we said or disease is going to tell us that there are 0 and 1 within their data set. Or we can say n levels of the same what variable within the data set. Then we say disease. Then we say that there are 2 levels. So it means that this will help us what convert on the particular variable of interest to the right what groups. So another one we will be interested in is to, for example, we want to also convert the age group. So the same thing. Whatever you want to convert is the same thing. So we want to always replace it with the same data set. Then we say assignment operator. So we want to, today we are just interested in factor. So I'm just going to place all of them as a factor. So age group. So I want to convert age group to a factor and replace it with the same data set factor. Then the same thing. Let me also do for educational level. So educational level. So in this case, go to educational level. Then we will just use these 2 variables against the dependent variable, that's the disease status in our analysis. So we want it to assign as a factor. Then you said that go into the data set. We are interested in what? Educational level. Then you are good to go. So this time, if you come back, then I say string of the data set. Then it shows that what? The disease is now what? A factor. Then age group is now a factor. The educational level is not a factor. Then we can now what? Handle them as what? A categorical variables in our analysis. Any question? So one thing I also would want to draw your attention is that, for example, programming language is very interesting because there are different functions. Okay, so for example, the scripts are used to do a particular analysis. Someone also do the same analysis by writing the script in another form. This is not really static like when you come to SPSS that we have a particular kind of format to follow. Okay, to kind of you need to click there to arrive at the number. But in the programming language like R, we are interested in the result, the right result. So the only way is that you're able to get the right code, do the right analysis, get the result. So someone can write a code of like 5 lines, and someone can also write a code like 3 lines and achieve the same results. So that depends on how friendly uh, we are on the particular hot pipeline of the writing. Yes, so today there's a lot of stuff I won't go into it. So that one, if you join most of our subsequent trainings, you'll be learning them, like how to rename all these numbers. We can also do that. I can rename using the levels. We can rename all the zero ones into now positive and negative, all those things. So I'll not be going into a lot of details today. I'm just going to stick into our objectives so that we can finish on that. Yes, thank you. Really good, Samuel. Yes. Yeah, so yes, I will share the script with you to practice. So I want you to follow and understand. Okay, understand. Yes, I understand this. Yes, we are able to do that. So with that, you can always create a new variable name, and reassign it using the values. Then you are good to go. Yeah. So I'm not. Yes, I'm going to some of the details today. Yeah, good, good. Yes. So these levels, you can use them to also rename your variables. Okay. You just have to create a new kind of new names, positive and negative, and reassign them, and you're good to go. That's all. Any other question? If there's time, I'll teach you. If not, I won't. Yes, any other question? So for the script and all those things will be shared with you after that. Okay. Yeah, so the next thing is I'm going straight to look at how we use this grouping. Imagine we just want to see how we use them to do one. Because if you look at how we analyze inferential stats, for categorical variables, we are mostly interested in the association between the two categorical variables. Okay, if it's SPSS, we first look at label it, then that will just give you a new names. Okay, but here we are going to do the cross tab, but in R, because already we've now assigned them as a factor, we want to kind of also create a new name. We want to say a table, or we want to say a cross table. So let me just do anything to represent. Yeah. Let me just say table one. Okay. So sometimes we don't want to use also a name that is a function in R. Let me just say cross table. Yes, like this. Okay. So we are going to first create one table. So one way for the current function we are using, it requires that we first create a table for the two variables that we are interested in. Okay. So in this case, we want to create a table, kind of a cross tabulation table. So it's using the function table. Then in this case, we still go back. So we are going to select. Mostly I copy the data name so that I don't end up typing those things. Now, how R also handle kind of either variables or naming is that is do like rows and columns. Okay, rows and column. So always the first one. So for example, if I say disease, then $sign. I want to first do age group. I want to create a table for this disease, comma. Then I said another one. I want to create a table of this way. So I want to create a table of what? Age group against what? The disease in this data set that we imported. Okay. So, what are how R create variables is that it treats the first aspect as the rows and the second aspect as the column. So this is very important because at the end, the next one I'm going to calculate the row percentage and the column percentage. Because in statistics, we are interested in those things. It's going to affect it. So I want to make sure that this is still a column percentage. Then we can what? Look at the frequency from that angle. So if I say table, then let's see this cross table. And R is also very case sensitive. You see, I started naming from what? Capitals. Okay, so it means that if I come here and I write cross table, okay, like this, then I run, it will give me error. It will tell me this is not found because I named the variables of capital. So I just want to make it caps. Then you could see that this is a table, okay, because this was the second one, I treated this as a column. So column of 0 and 1. Okay, 0, 1. Okay. Then we have what? The groupings. So we have 1, 2, 3, 4. So the age groups. So here, age groups too, it has a meaning. So I've not named all those things. Okay, so here, the age group that we created, we've now created what? Just a contingency table. In SPSS, we go to analyze cross-tab contingency table, then we select those two variables. Then we create this contingency table before we further what select the inferential start like chi-square, Cramer's test, and the rest. So the same thing. In R2, we first create the contingency table for the two categorical variables. Then from here, you could see these are the raw count, okay? Those that are 0, we have the raw count. So the age group of 1, those that have age group within 1, there are 32 people. Here, there are 69 people. Here, 66, here 58. Then those that are EX, we have 9, we have 11, 13. So this is the raw count being distributed by those variables. Any feature question? Yes. So mostly if you don't understand, yes, what is happening, then you can ask me to repeat, then we are good to go. We don't want to add more extra stuffs so that we're able to carry out today's information with us. Yeah. So today too, I'm not going to do any visualizations. I'm not going to do any graphs, anything. It's
So,
purely
Mr. Eben,
this. Yes, vision.
so it means that because these values are in numerical form, that's why
Yes.
we are seeing them like this. But if you convert them to factor, like
Mhm.
the cross tab you did right now, you see those
Yes, so this is a
those
factor.
variables.
No, this is a factor. So remember from the previous one, age group, disease, age group, and education level is some of the important variables we've converted to factor already. That helps us to create the contingency table. If you didn't convert it to it, it will going to create a very long thing for you.
Okay.
I don't know if you get it.
No, please.
Yeah, so now we are seeing them as a categorical variables. So that's why we easily create the contingency table with them.
Great
Can
one.
I say something?
Yes, Carson.
Okay, thank you. So
Mhm.
in the original data frame, the
Yeah,
age group, the
yes,
um, the age group, the disease, and then the educational level as coded as numbers. So R initially
yes,
sees them as numbers, but they are
yes.
categories. They are
Mhm.
categories. So to get them to categories, he used the factor function to convert them to categories. So we
Correct.
know that they are categorical variables, and then he used the table function to do the
Mhm.
contingency table, right?
Table.
So
Great.
yeah, so that's what he did. Other than that, the programming language would have treated the initial entries as continuous
Numerical.
variables, which
Yes.
numerical which
Or
they
continuous.
are not. Yes. So,
Exactly. Thank you for the perfect explanation. Yes. Mister, I don't know whether we are on the same level now.
Yeah.
Great. Yes. So, yeah, that is the workflow we've done so far. Because the kind of variable is very important. It's going to affect the analysis. This is not only in R, it's in other statistical software that we use. So a typical example is because mostly I teach SPSS and other software a lot. That's why I use SPSS as a perfect starting line. Mostly that's the starting point for data analysis. So if you look at those software, if you are not able to specify this, all your inferential star or descriptive statistics is going to be wrong. It's going to give you a red one. So if this was supposed to be a typical data analysis, we report them as a factor and we report the raw count. And the next one that we report is the percentages. Okay, so we can compute for column percentage and row percentage. So let's say column. So let's say data column percentage. We can also compute. So for that. So how do we do that? We can also do that with the function probability table. So we can say prob the table like this. Yes, I think that's it. Then in this case, this cross tab that we've done, okay, we need it. So I'll just bring that, okay, here. Then we can say there are two things. The second function, we call it, we want to look at margin, the margin function. That's what I use. You can say either 1 or 2. Okay, 1, let me bring, sorry, comment. If you specify 1, it's going to give you row percentage. So you specify 2, it's going to give you the column percentage. So that's just the next function attached to it. So let's say margin equal to 2. So hold on to make sure. So it's telling me you can't find this. I want to make sure I have this right. Okay. Okay. Yes, R is very red. I don't know why it gives error at first. So it's prop. Okay, so at first I did this one, proportion table. Yeah, that's what I did. Yes. So we use what we call proportion table. So this, as I said, if you look at margin, so let me repeat for another and use the 1 so that we know the difference. I'm just going to copy this code and paste on top. Then we know the difference. So the kind of percentage we report is very, very important. So it is this table that we created, this crosstab table. Then we had a count, okay. Then let's say we want to report the proportion alongside, okay, proportion, not prop. So I'm saying that you can just say prop table, proportion table, then the crosstab table that we created, okay. Then we said margin. So this function also helps us to specify whether it's row or it's column. If it's row, it's going to calculate it and give you the margin one will give you what? The row percentage. So if you look at here, 0.78, 0.21. If you add like this, row-wise, it's going to give you 100%. Okay. If you add this like this, it's going to give you 100%. For you to convert to 100%, you just have to multiply by 100, then you report them. But this is more in proportion. So it means that this one, it kind of cumulates everything in row-wise. So we can further, so we could see that this is what? In more of 0 to 1. Let me multiply by 100. Then let's see. So that then we are good to go. Then we have the actual percentage. So they say proportion first. At first, it was just in decimals. Then I just multiply by 100. Then we have the percentage. So if you add like row-wise, it's going to give you a total of what? 100. The same thing. But most often, we are interested in the percentage from the disease group column. Because when we are creating the table, okay, to report in our data analysis, mostly the disease group is on top of the data or the table. So we have yes or no. Then we report on the proportion. The raw count is the same thing. Then we need to also report the percentage. So the percentage, we are not interested in within the independent variable percentage. We are interested in within the dependent variable percentage. So most often we are interested in this one, the margin 2. So if I multiply also that by 100, so that to convert everything to percentage for us. So if I multiply that, so in this case, if you add it vertically, that's why it gives you 100. So within 0, those that don't have the disease, age group 1, we have 14.22, 30.66, 29.33, 25.778. Okay, then we are good to go. In fact, next thing, if you don't want to be stressing even your mind, you can further what? Even run it. So we can say run. We want to run it. So we want to run the same thing to, let's say, to one decimal point. Okay, then all the percentage will be what? Run to one decimal point. If you don't want to see, so after you've used this function to compute the percentage, then we can say we run it. We run to one decimal point. So it will tell you. So if you add what vertically, it's supposed to give you up to 100%. And those are the percentage that we report in the output. In a situation whereby there's kind of sometimes because of approximation, the percentage can be 101 or 99. In that case, we indicate as because of approximation. That's why the percentage is exceeding all that. But mostly, the within dependable variable percentage is supposed to give you what? Up to what? 100%. And you're good to go. Again, today I'm not going to show you how to create the tables and reporting. We are just interested in how to do this analysis rightly, in the right manner. So how to do other stuffs, there are a lot of things that goes on. This thing I've done, someone can do it in a different way, okay? A very interesting way and the rest. But as I said, as you know more function, that's why you kind of use them and you are good to go. So that's how we can compute. So now we've seen the raw count within those groups. So it's the same thing we put for any other variables. Then you could see that we can also look at the proportion. Okay, the proportion. That's what we do, like that. Then we report them. So that's how we analyze this kind of categorical variables, because most often Analyzing categorical variables, we are interested in what? Raw count and percentage for descriptive statistics. Then the inferential stat, we are now interested in what? The chi-square text, mostly either chi-square of association or independence or trend is the same chi-square. It's the interpretation, how we interpret the results that differs. Okay, the same thing. Then from that, we can now predict a groups. Then we are good to go. Okay, I'm going to add another code chunk. Okay, so now we have a table. Okay, and one thing I have to say is that you could see that most often we use R for visualization, all those things. So most often, if we are analyzing data, what is the best software to use? So it doesn't mean that you know R. So you want to do this, you want to come and use R. We are just learning how to appreciate all these things. But at the end, when you become a data scientist, you have to ask yourself first, what kind of software should I use to make my work very faster? That's the key thing. To make your work very faster, it means that some of these analysis, we can do them within seconds in what? In SPSS by clicking. Then we are good to go. So that in R, we don't need to be writing a lot of script for create table, to create this, but that's a lot. So in case that we have over 100 kind of different variables and we are doing this all for it, it means we have to write a very long code to combine all of them to give us a one each table. Yes. So let's see. So let's say we want to do chi-square. Then after that, we will look at the assumption to also do facial exact. It's very simple. So that one, we said from the table. So already we've created this table, the cross table, this one. We just have to add a function to it. So the function is chi-text. You just say chi.text. Okay, so if you start typing, it will come. So any of them, you just use it, then you put the cross table that you have, then you run. Then it give you what? The chi-square test. So it give you the chi-squared value, the degree of freedom, and the p-value. So we know all these different. The chi-square value is the text statistics. So in biostyle, we teach people how to calculate this manually. So then we know the degree of freedom is what? Is equal to the row minus 1 times the column minus 1. We can easily see it. What's the row minus 1? Is 2. 2 minus 1 is 1. Then the column, sorry, row is this one, 1, 2, 3, 4. Row minus 1, 1, 2, 3, 4. 4 minus 1 is 3. Times the column, we have 2 columns. So 2 minus 1, which is 1. So 3 times 1 is what? 3. Degree of freedom. So mostly we do all this. Then the p-value. We go to we use this chi-square value, go to the chi-square table and we trace the p-value. Previously, this is what we were doing manually, all those things before we come across all these things. So that's why I always say that mostly when we start with data science, we start teaching you the theory, the statistics, the meaning of all these things. Then we come to the application in the statistical tool. Even the statistical tool, the other software that we use to teach you to better understand it before we come to the complicated software like the R. Then you easily appreciate it. Any question? I don't know if you are following. If you are following, put one in the chat. Let me see whether we are following. Sometimes we will start. By the time we finish, we will end with few people. Yes. Today I want you to appreciate, appreciate the few, we are playing around with a few codes, better understand them. Then we can now subsequently learn more and do all the interesting thing you want to do. Yes. So I want to also try something. Let's say the same chi-square text. I want to see whether it can also give me see the expected. Yes. So this one. So what is the condition? The reason why I just did this, I want to also do what we call facial exact test. Mostly we can't talk about chi-square test without the facial exact test. So sometimes people will say that, but people have been seeing chi-square text, and some people also been seeing facial exact test. When do we use it? People will tell you that when some of the expected is less than 5. So a typical example is this one. Most of them are not less than 5. They're all huge, so it's good. But I will tell you that mostly we use facial exact test when we are dealing with 2 by 2 contingency. From the name, it gives you the exact what kind of statistics. Chi-square is an approximation of statistics, of association, of anything. So there's that. So in this case, if you go down into the mathematical formula of the facial exact, this one is very complicated. And this is what give you approximation. So most often, it's very recommended when we are dealing with a 2 by 2 contingency. 2 by 2 contingency means that where we have what rows, equal rows, and what 2 rows, and we have what 2 columns. Then we can do that. If you look at today's data set, like gender, let me go back and do cross tab for gender and use gender again. So I'm going to do another cross table. This one, let me add 2 here. Then table, then data. I want to copy. This time, I want the rows to be gender, then column, the same thing, rows to be the disease. So cross tab 2, I want to do the disease against what? Okay. So you could see that there's also a significant number of them. So, but we don't know whether, I'm not sure. So let me do chi-square cross tab 2. Let me see. But most often, our sometimes recommended, even if any of the expected is less than 5, okay, and we are just dealing with a 2 by 2. Me, sometimes I use the facial exact text that give you a strong kind of statistical uh, text to use. But the assumption is that first, are you dealing with 2 by 2? And the next one is any of the expected less than 5 or the percentage less than 20%? We're going to give you all those things. Then you cannot use facial exact text, but you can always do a facial exact text regardless. So if you want to do the facial exact text, depending on your situation, then you can also do that. So you can say facial. So you see, as soon as I've started typing, the thing comes. So I'm going to use from the start the base way. Facial exact, then I just put in what the cross tab that we've created. So the cross tab 2, I just copy into them. Then we are good to go. Then the same thing is going to give you the p-value. And you could see that facial exact mostly give you the p-value. It's chi-square that's going to be, well, this is a chi-square value, so don't expect to get this when you do the facial exact. So if you use any statistical software like even SPSS, as soon as you see facial exact, this one will be empty. Then you mostly report the p-value. Then you are good to go. And if you do a chi-square text for the same variables and you go and do chi-square test for Fisher-Exact variable, you are going to get a different p-value. So for example, these same variables, this time, if I run a chi-square, then you could see that the p-value here is what? 0.1942. Then Fisher-Exact test, you could see that 0.152. So at any case, any of the statistical software that you use, you are going to get a different what? Inferential stat result. So in this case, that's why we always specify after your entire analysis, you have to specify the kind of statistical approach that you use. Although they are all categorical variable, you have to specify whether this one uses what? Chi-square test or this one uses what? Fisher-Exact test at a font note below your table and you are good to go because each of them will give you a different statistical output that you can report that. Any question after this? So what is the importance of this? Yes, it's very important because it's going to tell you that. So if you look at this age group, okay, this is the disease and we have age group. Then when we did the chi-square test, it's telling us it's significant. Significant when the p-value. So if you have p-value is less than 0.05. Because this statistics is done as 95% confidence intervals. So it means that the null hypothesis is saying that at 95% confidence interval, there's no significant association between what age group and the disease. We don't know the kind of disease, but that's what it's telling us. So age group is not associated. That's the null hypothesis. But at the cutoff point of 5%, that is alpha value of 5%. So if you do the analysis and now the p-value is now less than the 5% or less than or equal to 5%, then we now go for the alternate hypothesis, which means that alternate means that significant association. Significant association. Okay. So that's what it means. But if the p-value, so for example, this one, that the p-value is 0.1552, it means that gender is not associated. So it's going to tell you that means gender is not associated with the disease. That's what it's telling us here. But here it's telling us what the significant association. That's what it's telling us here, and we are good to go. Yeah. So, but chi-square is just what telling us that the significant association, okay, of what age group. So it's telling us specifically, it's telling us age group is significantly associated with disease. Okay. But what is the next question? The question is what? Which age group is more significantly associated with the disease? That's the next question. Which age group is more significantly associated? And that leads us to what? The prediction models. So in prediction models, a typical example of prediction model is the logistics regression. So there's a lot of regression models. The two most common that you hear is the linear regression models and the logistics regression model. So in the case of categorical variables, So here we are going to try to answer this question. The next one is we've now seen that. So let me copy this thing. This is what we've seen. We've seen that age group is what? Significantly associated. So the next question is, which age group is more significant? So to answer that, that's why, because one, the dependent, so dependent variable here. What's the dependent variable here? Is the disease status. And what is it? It's a factor. Because it's a factor, then the best sort prediction that we do what we call the logistics regression model. And what is even the kind of logistic regression? This more of is a univariate. We are going to analyze this 1-1. But because this factor, what are they? They are what? The person is either 0 or 1. So it means that it's a binary. So if you go to software like SPSS, there's different logistics. We do binary logistic regression. We can do multinomial, different kind of logistic regression. Okay. Oh, what I'm saying, if you join a detailed training right from start, we will take you right from all those angles, then you launch here. But here, you are trying to look at how interesting this pattern is. So right from chi-square, this is just to tell you that when we are doing a data analysis, the first kind of analysis we do is on the descriptive start to look at the rep count and also to look at what the percentage. Then we now move to the association with the chi-square. And if there's significant association, we now move to what we call the logistic regression to see which of the age group is more associated. So today we are just focused on the logistic regression. Then that will be it, which should be interesting. So how do we do this? It's also very interesting because we've already set all these things as groups. So let me add a code. There are different functions. Some people, mostly you will see LM. That is more of a linear regression model. But today we are going to use GLM function. The GLM is more for the logistics. We mostly also deal this in more logistics. But today we are just going to use this function. Let's see how this one also play in the general logistic regression models. That's what. There can be other functions. As I said, if you look at all these functions, you can just look at function to do logistic regression. It's going to give you a lot of functions to do that. And it also depends on the package. It's going to modify your function. And you can always modify this function to do different things that you want. Okay. So, but today I'm just going to try this GLM to see what happens. It could be that you just go online or other functions which work best, you can just use it. Yes. But the thing is you need to answer a research question or a statistical question or aim or objective of the person work. The next thing, because we've used chi-square to see that age is significantly associated. Okay. Then you want to see model. So I'm just going to name this L model. We want to continue with a model. So in this case, we can, let me just GRM. Then, so this is the function. So what I also want to say that writing function in R, it kind of a bit also different when we want to write function in other software like Python. Okay. So most often I do function first. We can also have other approach like where people use the piping like approach and all those things, but mostly I bring the function and I specify every other things in kind of within
Ben.
it. Yes.
Sorry, I'll take you back somewhere.
Mm-hmm.
we are using the linear model because the chi-square is the p-value is significant, right? But what of a case whereby both the Fisher exact test and the chi-square are significant, clinically significant?
They are
What are we
not
supposed to do?
significant.
Like, I mean, the two of them. I mean, in a case whereby the two of them are significant.
Okay, so most often, so I use the tool here is just for us to learn how to do this. But in typical data analysis, the same variable, we don't use the tool. So it could be that we have 10 variables in the table, right? One of them you use chi-square, and some of them you use Fisher exact. All of them is just to determine association.
Yeah.
Okay. But the same variable, you don't use chi-square, then you can't use Fisher exact. So the
Yes.
reason why some of the variables you use Fisher exact, some of the variable you use chi-square is when one, there's most often I'll tell people that when there's 2 by 2 contingency table and expected is less than what? 20%, that's what you read in literature. Or the count, mostly you see zero. As soon as you see any of the raw count less than 5, you see expected less than way. That's your 20%. Then you use them, you use specializer. So it means that in the same table, you see maybe age group, it was analyzed by what? Chi-square. Gender was analyzed by what? Fisher. This was analyzed by this, depending. We have to also remember that today I've not touched on any continuous variable. How we handle continuous variable is also really different. I can take you to a lot of way, and it's very complex. Where we talk about the independent sample t-test, Mawiti test, Quakrawalis test, Wakosin sign racks, all those kind of tests. It's also different. That's the whole thing on its own. But for categorical variable, what we are saying is that for association or differences, mostly we do chi-square. And the chi-square will tell you there will be what? Association. Associations or not. But when we do this, okay, whether there's significant association, it's just going to tell you that the association is for the whole group because it gives us only one p-value. Okay, just one p-value. But we want to see what is the association of the individual groups or the sub-levels within the categorical variables. That's why we proceed to do the logistic regressions. Okay. And the logistic regression is going to give you individual p-values or odd ratios for each of the groups. That's what it's going to give you. Yes. So someone could also ask that when do we always have to continue to do this advanced analysis? In fact, you see a lot of people, the analysis just end at the chi-square level. Okay. But currently, if you want your work to be published or you want your supervisor to see you've done high level work, we don't end up chi-square. You proceed to do the logistic regression to get the odd ratios. Okay, that's where we get the odd ratios. Then the odd ratio will tell us the increased odds of what? The age group having the disease. Then the next question is, let's say you have 10 variables in the table. Okay, then let's say 2 of them are significant. 8 are not significant in the chi-square model. So either chi-square or Fisher exact. The next thing is, do you proceed to do what? The odd ratios or the logistic regression for all of them? Yes. We proceed to do. So as soon as you want to do the logistic regression, you have to do for all of them. That's why first you do the univariable logistics regression. The univariable means that we are still going to text each of the variable one after the other. And most often, if a chi-square is giving you an association that is significant, if you do the logistic regression, the crude odd, so the first univariable, that's why we get the crude odd ratio. So mostly from here, we get what we call the crude odd ratio. is you by all means also see it to be significant. But after that, then we ask ourselves, is there any co-founders? That is where we do adjustment by other co-founders to proceed to do the adjustment or ratios or the multivariable logistic regression. Then we get the adjusted or ratios. Yes. Yeah. So simply, yes, when you get after you've done the chi-square, I recommend that you proceed to do the logistic regression. And most often we do this easily with other software like SPSS and the rest here. Today we are just kind of recreating the knowledge we have in aspect of what R. That's just the basically goal for today. So if you want to really understand this, you join our training that start from other softwares or constant trainings, then you get all the overview of this, then you can easily enjoy all these things in R. We are just trying to today tell ourselves that a lot of things we know in other software, we can replicate them in R. So R is a perfect tool to replicate a lot of things that we know and to give you an advanced result, especially when it comes to visualization, which today I'm not dealing with visualization. I'm just trying to do only analysis to see how it goes. Yes. So we can say that we want to do, okay, just disease, let's say disease against the age group. Let me see how. So it's also good to, especially when it comes to the variable names, if you misspell it, you get error. So mostly don't want to see any error when writing code. So make sure you are dealing with the right names and the rest. So it's very case sensitive. So against this, then we specify the data that we use. So data equal to the DD data. That's all. Then it has also another function that we have to specify the family of it. We say binomial. We want to do it a binomial. Then we analyze. Then we can now view the result. Mostly, if I want to view the result, let me see. This one will give you a lot, intercept and the rest. Or some people, even you see their code, they'll add summary, then they will now view their result like this. So this is the best way, together with the summary. Then you could see that it's going to give you all this. But before that, there's one thing that I mix. Okay, there's one thing that I mix is to set reference. Okay. Yeah, because I already analyzed it, that's why you are seeing this result. But you might not see this result until you do something. What is the thing? Is to set reference. You need to set reference because sometimes you've read literature, okay? Then in the literature, you saw that, oh, people that are older, they have increased chances of having the disease, okay? Then it means that we want to compare the older age group to the lower age group. So in that case, we set reference when we are doing the analysis. So we are saying that we go into the age group. Then we say, so we are just going to set reference here and replace it with the same data set. Okay, so R level. Yes, this is the R level. The same thing. Then age group. Then in this case, I'll say ref. Yes. So you see R level factor. So this is within this function is what it's from this package. Then we say it's 1. Then we set the reference. After that, I'll change it and reanalyze it. So it means that we are telling that in the dependent variable, In the dependent variable, we want to see how they have the possibility of having the disease compared to the younger age group. So if you're able to set this, replace it with the same age group, then before you come and do the analysis, after that, I'll change it to 4, then we see, then we have it, then we have this result. So in this case, you not see the results for what? The age group 1. So you see result for age group 2, 3, and 4. Then it's going to give you all the result that you need. Okay, this is just the p-value. Or we can also set the 4 as now the reference. Okay, then I'll analyze it. Let me comment this. Then you could see that this time what? Because I set the 4, I said I compare all the variables to 4. It will now give me the result for the age group 1, 2, 3. In fact, this result is very straightforward to see that the result there are for age group 1, 2, 3. Software like SPSS further does a lot of recoding. Okay, recoding before it gives you the result. It doesn't give you straight. Now, this one is just giving you the p-value. You need to further proceed to see the odds ratios and the confidence intervals. So we will say that expect, we want to see the expected, okay? This is also more of a base R, the expected of the confidence. Let me see what happened to this. Let me see whether this works. Exactly. Then we have this result. So this, hold on. Let me be sure that is the odd ratio. Okay. Yeah, good. Yes. So I'm just kind of extracting the expected or odd ratio. So if you look at here, it gives me that compared to the age group 4, that is the higher age group, okay, the age group 3 people has 1.10 odds. This one has 0.29. This one has 0.5 chances of having the disease. Why I'm not talking about the disease is that what is important about the disease was already coded 0 and 1. And most of these models, they predict for the highest coding number. In SPSS, we'll be able to specify some of the dependent variable coding, but for example, some of the independent variable, but the dependent variable, it's kind of by default, it picks. I've not really checked that with the R, but I presume that it always code for the highest coding number. So if you look at the disease status, we coded them what? 0 and 1. So that's why right from your data cleaning and coding is very important. So the kind of analysis I'm going to do will tell you how you code the data. And if you know you're going to do prediction models, especially for the dependent variable, that will tell us how we can even code this data. Then we are good to go. So I'm going to say final results. And final, let me just say FR. I want to extract the whole result, okay, using the C combined function. So assign C bind. So this time, so this is the alpha. So let me also first extract the confidence intervals. Okay. So this is just the coefficient of the variance. So I'm going to use the same thing, the odd confidence intervals. Okay. Then I'll extract that. The same thing, you want to see what is happening. Okay. Then this time, we want to see this one. Yes. Then the models. Where's the model? So as we get to more advanced, some of the stuffs, then I just want to first extract the results for you to understand. Then we come back to see what's happening. Then we are good to go. So we have odd ratios. I'm going to name this as odd ratio. It's equal to the confidence interval, this one. Then I'll say that the confidence intervals. Let me see, is there a question? I'm coming to check your question. I want to see what the final result looks like. Yes, this is what I want you to see. The final result for the odd ratios and the confidence intervals. First, this function that I use here gave me the odd ratio, which we saw up there. So this odd ratio. So this odd ratios, and I also extracted the confidence intervals. Okay. Then I just combine them so that we kind of interpret what is happening. Then we go back to see. So this basically is what we are saying is that compared to the age group 4, okay, the age group 4, the age group 1 has 0.5 decreased chances of having what? The disease. Let me see. Okay, yes, someone is saying Bloom Library. Good. Yes, custom. Great. Yes, so that's also another way function. So someone has also put another, yes, another good function in the chat. I'm not sure so myself I've not used the Boom package yet, but I see, so you could see that this is very kind of a very short way to do this, which is nice, yes, which is nice. Yes, 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 yes. Great, great. Yeah, thank you. Yeah, so that's why we are a community and good people contribute. Yes. So for me, mostly this is how I kind of step by step combine the results. Then I'm good to go. This is just for learning. By practice, you need to kind of adapt things that work for you. Okay. I just want us to understand the workflow we have here. That is a categorical variable we are analyzing. Okay. Categorical variable we analyze. Then we started from what? The data. So we imported the data, correct? Then we look at the data. Then we ask ourselves, is the data in the right format? Then if it's not, we converted it to the right format. Then because we are going to handle categorical variables, we are interested in what? The raw count and what the percentages. If it was to be continuous variable, that's what we'll be talking about, the mean, standard deviation, those kind of analysis. So that's why today you've not heard me talk about all those things. We are focusing on what? Categorical variable. So hopefully as you join most of the subsequent RSS community training, you get to love all this stuff. So it's very nice, yes. So we just want to see how we kind of the workflow in this angle today. So we are interested in raw counts, we are interested in percentage. This is how you can extract your percentages. It's either you're interested in the row or the column percentage, which I explained to you. Then we want to see is a crosstab. So we created a crosstab and then we can do chi-square. If you think your data doesn't fit a chi-square, the alternate inferential status do the Fisher exact. Then from there, if you want to see whether there's any special group, anything about your variable, then you proceed to do what? The advanced analysis. So this advanced analysis will give you the odd ratios and the confidence intervals. Then you could see that it first gave us the p-value, then use them in the analysis. Then you are good to go. So if you look at this group, let's look at this group. So sometimes if someone do a cheat, okay, we can detect the person. So for example, let's see what is happening here. You could see that age group 2, what's the odd ratio? 0.29. The lower confidence and the upper start from 0.13 to 0.66. Then we can easily see that when we further see the p-value, this age group will be significant because there's a way we draw a reference for odd ratios and how we interpret them. Some of the tricks we reserve them, we'll be teaching you as and when we learn together. Okay, any question? Feel like yes, any question? Right now we've spent our 2 hours already. Okay, yes, it should be, time up. Yeah, any question? If not, we've exhausted our 2 hours and we may have to end here. Yeah, any question? So we started with like 35, then we are ending like 20. We are happy that we are all here. Let me see whether Ruby is here. Is it Ruby? Yeah, she's here. Good.
Yes, I'm here.
How did you go?
It's the first time, so I'm following.
Great. So,
Mm,
what is the
I'm
experience like? Do you think
Yeah.
do you think you are good to go coming forward?
I think after today's session, I'm a step ahead.
Great, great,
So
great.
I'm
Yes.
going to get, I'm very optimistic. Yeah.
Yes, yes. So I'm happy that your hope is high. Yes, yes. So I tell you, the first time I joined our training, I went back. Then a month time, then I came back. Do you know who brought me back? Pastor Samuel is not here. I went back, I was like, I'm not for R. I went back. Then a month's time, then they recommended the community to me and I joined. So this is the best place. That's why we are here to help you to develop way. Yes. Yeah, so someone is asking the LM and the GLM. So I've not really dived into this function yet, but mostly I presume the LM is more recommended for the linear regression models. Because anytime you search more on the code, the right code to do the logistic regression, they recommend the GLM, which is
Okay,
the general linear regression model that can fit in other models, except someone also have any thoughts. Yes.
can I contribute?
Yes, yes.
Okay, so as you rightly mentioned, the LM
Mhm,
is just for
mhm,
linear models. I mean, not
mhm.
linear regressions. Sorry, that's
Yes.
the correct term. Linear regression, where the
Regression
outcome variable is a continuous variable.
continuous. Yeah.
Uh-huh. But for the GLM is general. That's what I say,
Yes.
generalized linear model. So the
Regression. Yeah.
generalized linear model
Mhm.
allows so you can use the generalized linear model for
More
where the output,
specification.
yeah, for outcome,
Mhm.
the outcome can be a continuous variable. The outcome can
Mhm.
be a binary variable like
Mhm.
we did in
Yes.
this case. The
Yes.
outcome can be a count. The outcome
Mhm.
can be a proportion. So yeah, so the generalized linear model allows you to fit many different types of outcome variables. So you specify the type of outcome variable in the family. You see, here you said the family equals binomial,
Yes.
which
Yes.
is referring to what we are doing,
Yeah.
binary variable. So there are other kinds of families. Family equals Poisson. Family equals negative
Plenty.
binomial. So
You
I mean,
see,
there are a
even
lot of
Persian way, those kind of
yeah.
Bayesian regression,
Yes,
they are all
So
there.
yeah, so the GLM is general. It allows you to fit many different kinds. But for the LM is just for linear regression where you are fitting only a continuous variable. So you can even use the GLM to fit a continuous variable. You just indicate the family equals, I think identity or so. I've forgotten.
Yeah.
Then yeah, so that's what it is.
Also for the contribution. Great. Yeah. So that's why Ghana Research Community is the best place to be. Yes, if you don't understand anything, even from the one teaching, someone will explain to you, which is very good. Yes. Yeah, so that's it. LM, you see, for linear regression. So mostly people confuse linear regression from logistic regression. People just know regression models or logistic regression. So sometimes we even go back to teach what is the difference between linear regression and logistic regression. They are not the same thing. So the kind of variables we are working with inform what you are doing. It informs a lot. So that's why we say that you can't just stand up and say you are doing this, you are doing this. We learn from the basics, what to do, then you now fit into the right, and you become very competitive wherever you go to work or you do this, and you are happy that you are doing the right thing. Awesome. Yes. Any other question?
Please, I have a question. How many years
Okay.
does it take to become a pro in R? What are all the strategies used to
So I would say it
tips and
doesn't take
tricks?
years. It takes only consistency. Yes. Someone can be very consistent within 1 year. The person is a pro. Someone can take 10 years. The person will just do R maybe once a year. Then you take 50 years, you die, you still go and learn R in the way, cemetery. I'm just joking. Yeah. Yeah, yeah. So the key thing is consistently. So sometimes, I just work on a full book. It's almost done. If you go into after that, I share the screen. So this kind of holidays, what I was doing, I was just working on my book, R for molecular biologists and immunologists, where I've written a lot of code right from my years of experience in using out all the data I've analyzed. Now I have them in my book. So it's consistently, even as a result of me writing the code, I even learn new things to modify this. So even the code, in fact, the code that I've used right now, the next thing you'll be doing, you even get new things. Then it build a kind of your skills and all those things. So it depends on what you are doing and your consistency in using the tool that will make you a pro. Someone will say consistency beats talent. If it's your talent and someone is consistent, you forget. It doesn't mean that no one is born with it. Someone is having a talent, someone is always practicing, like going to training. You cannot beat such person. Yeah, so we just work on project and all those things, then you're good to go. Yes, we will share the book with you. So far as you are part of the RGSS community, when it becomes available, I'll share it with you and you're good to go. Yes. It's from scratch, from data analysis, like the thing we've done. So we teach typical data analysis from biological data, handling all those things to all the scripts to visualization. Yes. So I'll be happy if you join me some of the sections next year. This year was very tight. I apologize to the Ghana research community. I will be involved in a lot of stuff. But my very good friend George has been saving us. I'm sure those that joined a lot of George section, you benefited. Yes. So thank you, George, for this year wonderful thing you've done to the community. So myself, I was very weak. Myself is not easy. Yes. So hopefully next year we'll come back strongly, continue to build this community, and those that are interested will continue to have these trainings. Yes. I'm going to stop sharing my screen because I'm done. Then, yes, in case Alex, anyone has a question, I've seen that founder of Ghana Research Committee is here, George, with Francis, George, or George, if you have anything, if not Francis, if you have anything, you can say yes. If not, we'll bring today's section to an end, and I thank everyone if you for joining me the first time or even our pros. So Julius, we will address your section. I don't know whether I should address Julius comment now, but the reason why I'm not addressing how to rename the name is I want Julius to join us in another section to know how to use the levels to rename that's why I want you to join. Okay, yes, Julia, that was a good question. So mostly you just have to create a new name and you level it to the, but I just didn't show it, which is really good. Thank you very much. Yes. Yeah, any other concern, anything?
Yeah, please. There's one thing I wanted to ask.
Mhm.
Yeah, it's
Yeah,
about the confidence intervals, the ones
okay.
that didn't cross one, and the
Mhm.
others. Do you report all of them together in your
Yes, yes, we
or
report all of them, but the interpretation differs. So I said, mostly if you join more of advanced training, we will teach you all this into details. Today, just kind of, we are just looking at it. So we will teach you all those things. How do we report? How do we interpret those data? It's yes, it's all the we teach you all those things. What does even those that we see, what does those mean? What does it mean? Confident interval of more than one, less than one. What does it mean? We teach you all those stuffs. Yes, which is really good. Yeah. Awesome.
I would like to say that I mean R is a statistical programming language, so
Mhm.
it's used for statistics. So if you don't have a foundation in statistics, it becomes difficult to learn R as well because you are so whilst you are learning R, you should be learning your statistics alongside because you
Exactly.
invariably are going to use R for
Statistics.
R for statistics. So if you don't know statistics, R becomes
Yes.
very difficult. So if you
Boring.
know if you know statistics, then you learn how to use R to do the
Stats.
statistics. So when you're learning R, you learn statistics alongside, and then alongside it. So that's the problem that I've realized a lot of people face that their foundation statistics is very poor, and then they want to learn R.
Exactly. Yes.
Mm.
Good. Exactly. So mostly, as I said, most of our intensive trainings, we start teaching you right from the statistics. Whatever information I've given you is just kind of 0.0% of something. We will teach you what kind of tools you'll be hearing. One way and over, you'll be hearing all the once I put it, you'll be hearing all those things. But what does it mean? When do we use them? When do we use them in analysis? We teach you right from all those steps coming. Yes, but most of this webinars is kind of a snapshot to kind of deep into one topic. Yeah, so sorry if you don't get anything right from there. It means that it's just a piece of information from the entire chunk of information we have out there. Yeah, yeah, good to go. Okay, any other? I say, mm, okay, all right. So yeah, so if there's no other question, Judge, are you there? I think Judge is not there.
So I'm here. I think George just left.
Oh, okay, okay, yes. So I wanted to close the meeting. I'm done, and unless you have any information for them.
Okay, so I think I don't have
Okay.
information, but
Mm.
I just want to thank you very much. I think it's not easy. I know you're in the state and then
Yeah.
you are doing your PhD and then
Yeah.
today is I think kind of like a Christmas season.
Yes. Yes.
I think the attendance we have like 34
Yeah.
people that
Yes.
earlier joined, and I
Mm.
think it's encouraging. And as you
Yeah.
said, some of these things come with the statistics aspect.
Mm.
So we'll be doing more of that maybe in the
Mm.
coming year. And then we would like also to encourage you, those who want to be mentored, you can maybe DM Eben, can DM Eben, it can take you through series of classes or sessions for you to even get to understand it. So I just want to really thank everyone for joining. And then, yeah, so may God bless us all. So I think we also have lots of programs coming up. So God willing, January, I think we'll start with the advert and stuff. So if you want to learn more, you can join. And if also you want a one-on-one session with Eben, he's a very busy man. You have to DM him, then probably you book a session. Yeah. But then, believe me, one-on-one session is very expensive. So if you are going for one-on-one session, Ruby really wants to learn the R. So Ruby is saying how much?
So I've never done any one-on-one to
I want to
mostly
learn.
recruit.
I want to become a
Yes,
pro.
yes. I think Ruby is one person that's really motivated in this session. Ruby, are you part of Ian? Are you part of any of our pages? How did you
The
join this
Aaron
training?
user group. Is it
Okay.
user group or user group? Is it
Yeah,
WhatsApp group?
the Ghana R is a
Oh,
group.
great. Okay. Ian Morgan, which pages are you on that you were able to join this training?
Never.
Not on any of the groups. I just saw this on LinkedIn and then I
Okay.
joined.
Okay, so great. So the link you join, I'm sure it was shared either from either Ghana Research or it's from the Elite Research and Data Science.
The Ghana R users page.
Okay, great. So it means that I don't know, Francis, can you share the Ghana Research WhatsApp link here?
Yes.
Okay.
Wow, unless I connect my laptop. Just a minute.
Oh, then
Can you drop your number for me so that I just kind of copy it and probably add it to the page?
yes, if not, you can also send email
Okay,
to.
so Eben, let me just send it to you. I haven't. Let me
So what
send
I'll
it
do is,
to you.
okay, send your email to my institute page at so just send email to this. I will send you, we'll add you to. Okay, let me
So
try and
I just
add.
shared the link. Maybe you can just copy it
Okay,
and then paste it on the chats. I
okay.
haven't done that with my WhatsApp phone, so
So
I
I'm
realized.
just going to DM you now with the link. 2, 4,